I'm Yael Doweck. I work at StarkWare for the past 2 years, and I'm a product manager and researcher. And today I'm going to talk about scaling blockchains with Starkx, which is what we do in StarkWare. First I'm going to present the problem, the blockchain paradox. So we have Bitcoin, who was launched in 2008, and Ethereum was launched in 2015. That's a relatively new technology, but why is this technology so slow compared to Visa? In Ethereum, there's about 15 transactions per second, and in Visa, there are a few thousand. And that's very surprising because it's state-of-the-art technology. Why is it so slow? So this is all because of I don't know, I can't. Okay, yeah. It's all about computational integrity. I don't know, my slides didn't move for a minute. So we need to find an efficient way to make sure that the computation that was done on chain was indeed correct and that the new state is valid and it's not malicious. So today, most systems work with trusted parties such as banks, accountants, audit firms. So in fact, we delegate the accountability to someone else, someone trusted. We deposit our money to the bank, and the bank makes sure that everything was done correctly. Whereas in blockchains, there's inclusive accountability. Anyone can join the network and anyone can verify that everything was done correctly. So it's enough that you have a laptop and you install a full node of blockchain on it, and then you become some kind of an audit firm for everything that happens on the blockchain. So there are two sacrifices that we do when we use inclusive accountability on blockchains. The first one is privacy. So in order for everyone to be able to verify everything that is happening in the blockchain, we must have the entire information public. So everyone in the network will know that I bought bread this morning from someone else, from Bob, and I paid $10 for it. The second property that we sacrifice is scalability, which is the one we're going to talk about today. So since every node in the network must be able to verify everything that is happening, we actually rely on the most on the weakest link in the chain. Okay, so our mission in StarkWare is to scale the blockchain, but without hurting the inclusive accountability. So actually, the state of affairs today is that you need to decide if you want to deposit your money into a central bank that relies on a trusted big computer. It is very fast. You can do many transactions per second, but you need to trust this entity. Or you can deposit your money into blockchains and you don't have to trust anyone, but sometimes you feel like you're stuck in the worst traffic jam ever. Let's try to solve this in one way. So let's say we decide to increase the block size, the gas limit by 100x. So what will happen is that there will be some computers, these big computers that you see from both sides of the graph, that will be able to handle the load and to verify each and every transaction that happens in the block. But other nodes will not be strong enough and won't be able to verify this TPS. So unfortunately, my laptop won't be able to handle the load, especially if I'm running other things as well, not only the blockchain node. And this, in fact, brings us to an exclusive accountability, which is more of the same, like banks and other trusted entities. Okay, so yeah, the slides are a bit jumpy. So what we do in StarkWare, we use validity proofs in order to solve this problem. So this uses kind of the best of both worlds. We still have the big computer that does the big computations and it computes the new state of the chain, the new state of the system, and computes the proof that is attesting to the validity of this state. But on the other hand, you don't need to trust this computer. You just need to trust the math. And the proof is sent to the blockchain so that anyone can verify the validity of the new state using the proof. This proof scales, the proof verification scales polylogarithmically with the size of the computation. So anyone with any laptop can verify the proof. So what is a proof? Let's look at this receipt. This is a proof that proves the following statement. Someone, the customer, needs to pay $89.50 for the meal that he ate. In this case, the prover is the party that produced the receipt, the restaurant owner, for example. And the verifier is the party that is checking the proof. This is the customer. He needs to check that the computation was done correctly, and he indeed needs to pay $89.50. The way that you will verify this receipt is by replaying the computation, meaning you will sum all the prices and see if he reaches the same total sum. Stark proofs are they achieve the same goal, but there are two differences. The first one is that they have the property of privacy. That's what ZK stands for. It's zero knowledge. So, for example, in this receipt, you will see some of the lines will be deleted, and you won't see all of the items that were included in the receipt. You won't be able to see what I ate in my meal, but you will be able to see the statement, the total sum, and be able to verify that the total sum was computed correctly. The second property that is different is the scalability. So the verification scales polylogarithmically with the size of computation. So this reduces the amount of computation needed to verify the proof to a few single steps. And the proving time scales quasi-linearly with the size of computation, like t log t, if t is the size of the computation. Okay, so in this case, the prover can be a very big computer, and he's generating the proof, and the verifier can be a small computer who only verifies in polylogarithmic time. So the proof can now be sent to the blockchain, and the nodes in the blockchain, they don't have to be very strong computers, and they can still verify the proofs, and they don't need to trust the prover for anything. This is how it basically works. So there's a prover, he receives a very large amount of transactions, and he computes the new state of the system and sends the state along with a proof that attests to the validity of the new state. This is sent to the Ethereum blockchain, and there's a contract called the Verifier Contract. This contract verifies that the new state is indeed correct by verifying the proof. So you don't need to trust the verifier, you just trust the math. And just for the comparison, in Ethereum, one block fits 150 NFT mints, while when you use ZK Starkx, one block fits 3 proofs, and 3 proofs contain around 600K NFT mints, which means a block can contain 1,800,000 NFTs. It's a few orders of magnitude larger than the amount of NFTs that could have been minted on a native Ethereum. In StarkWare, we have 2 lines of products that use the Stark technology. We have StarkX and we have Darknet. So here are a few numbers about StarkX. So StarkX, since its launch, it's in production for about 2 years, since June 2020. And we have a cumulative trading volume of more than $500 billion, 184 million transactions settled, 60 million NFTs were minted on StarkX, and we have actually 5 systems in production. DYDX for perpetual trading, Sorare and Immutable are doing NFT marketplace. Diversify are doing spot trading, and we also have Stellar, which is not mentioned here, for Defy Pulling. So a bit about Starkx, how it works. So here in the diagram, you can see in the pink area, that's the blockchain part, and in the white area, there's the off-chain part. The StarkWare actually writes all the part that in the right side of the screen. The only part that is written by the partner, the application side, is the square that says application. So what happens is that users on layer 2 off-chain are sending many actions, operations to the application, and the application processes them and sends them to Starkx in the form of transactions. It's the available transactions are settlements, NFT minting, transfers of funds, and deposit and withdrawal. The Starkx service computes the new state of the system. There's a Merkle tree, and the root of the Merkle tree will be the new state of the layer 2. This entire batch of transactions that were processed by Starkx is sent to Sharp. Sharp is a shared proving service. So that's the prover that we discussed before, the Stark prover. And this shared proving service, it's shared because it is shared among multiple applications, not just this application. And it takes all the transactions and proves that every step in the computation was done correctly and that the new state that Starkx computed is valid. This proof is sent on-chain to the Stark verifier on Ethereum for anyone to verify that the new state is valid. And then a state update is sent to Starkx contract. That's the root that you see in the bottom. And this root is only updated if the verifier indeed said that the proof was done correctly. So what can we do with Starkx? The first use case is an NFT marketplace. That's what Immutable and Sorare are doing. So users can trade their NFTs. The application can send minting requests to Starkx. And if any user wants to withdraw the NFT to layer 1 and do anything else with it in a different DeFi application on layer 1, he can do that and withdraw from the layer 1 Starkx contract. Another use case is Defy Pulling. So today it's very, very expensive to invest in layer 1 DeFi. What we offer in Starkx is for users on layer 2 to aggregate their funds together into a pool of funds, and then they can send the entire pool of funds together to layer 1 to a DeFi strategy to deposit, and then they can split the cost, the gas cost of layer 1 between them, so they don't have to pay the entire cost. they only pay for their portion of the pool. And they also earn of course, the yield according to the portion that they deposited. And the third use case is leverage trading. This is used by the YDX. So Starkx has a few additional transactions that we added support for leverage trading, perpetual trading. It's transactions like Oracle price updates and liquidations. These are the operations that are needed in order to support the leverage trading logic. And the second line of product that I mentioned before is Darknet. So Darknet is a layer 2 blockchain, actually. That's a general computation platform. It's secured by Ethereum because we always send the proof to Ethereum to be verified there. It allows writing smart contracts in Cairo. Cairo is a programming language that we developed in StarkWare that allows providing proofs for any general computation. And the cost of execution is very low due to the Stark technology. So there's no re-execution of every transaction by all participants because they only need to verify the Stark proof. And due to that, you can execute more computation in this layer 2 network. Okay, so thank you everyone for listening. If you want to ask me any questions, you can DM me on Twitter or find me in LinkedIn. And I'm happy to chat about Starknet, Starkx, and everything else. Thank you.
Thank you so much, Yael.